Hello, Sammy.
Hi, Dag. Hi, Henk.
Hi.
All right. So, we're going to start. Henk, thank you for joining us today on Dataminds Connect. To give you a short introduction, who Henk is. Henk was a Microsoft MVP in AI. Now he's a senior cloud advocate at Microsoft. He's the founder of the global AI community. He's doing a lot of work for many different communities, setting up technical stuff behind, but also organizing many different things. I'm personally very happy I can work with him regularly together. So with this, Henk is going to talk about bringing models to the next level with Azure machine learning. For sure, I'm sure it's going to be a very interesting talk. And with this, I'm going to give Henk the platform. If you have any questions in the meantime, please don't hesitate to use the chat or to raise your hand. Henk loves to be interrupted during his talks, so really don't hesitate to do. Henk, the platform is yours.
Thank you. And thanks everyone for joining me. Good morning, good evening. I think most of you are from around here. I don't know. So today we're going to talk about how to take our models to the next level with Azure Machine Learning. And in this session, we're going to have a look at a very specific part of machine learning, natural language processing. So first, we're going to have a look at text analytics with Microsoft Cognitive Services. Then we're going to see how we can quickly build a model with automated machine learning. Then we're going to build our own models with Azure Machine Learning Service. And then later we're going to use hyperparameter tuning to optimize our model. You can all do this yourself. These short links, I will share them afterwards also. So let's start with a story. So we're going to tie this all together with this company called Tailwind Traders, which is a global retail company. And they want to expand into new retail markets and are evaluating the closing space. Initially, they have no knowledge of machine learning or natural language processing. So they want to start with something simple and then build their experience to create more advanced models. So we'll walk you along the path that Tailwind Traders will likely take when developing their next text-based analytics services. So first, we're going to look at cognitive services. Because I also personally think if you want to solve a machine learning problem, and there is already a service that actually solves that problem for you, that is a big win. And it's very easy to integrate because these cognitive services are mostly REST APIs you can connect to. Simple API call or easy API call, just send some JSON to an endpoint and then get it back. They're also very flexible because it doesn't matter if you use Python or C# or Node or run on an Apple or on Android. They all work. They're all APIs in the cloud. And a very big bonus is that they're tested. They're created by our teams from Microsoft Research, and we also use these services in our own services, like Bing, for instance. So the first thing I want to show you is the text analytics service. So if you want to determine the sentiment of a sentence, in this case, reviews, then you can send that piece of text, the review, to this endpoint, click Analyze Text, and it will tell you a lot of great things about this service. In which the review extract phrases from it, like, hey, this is about the service and food about a restaurant in London. It can tell you if it is meant positive or negative. We'll dive into that a little bit later because that is what our model is all about, what we're going to create. And it can extract named entities. So it finds in a sentence, hey, this is about London, and London is a location. And then let me help you and link this to a Wikipedia article. So I'm not going to dive in too much about how to call an API. This is all available on our docs page, where you can go, find a sample, and do this yourself. So I want to go on that journey, like how to go from Microsoft Cognitive Services to Azure Machine Learning, and basically from a pre-built model to how to do it yourself. But there is one thing that I noticed, like cognitive services solve mostly 80% of your business need, but there is always that 20% that it doesn't solve. So, and for those 20%, we have to create our own models. So take a look at this example. Love the sweater, but hated the pants. So this service, this out-of-the-box service, just gives us like, hey, it is negative. It just looks at hated the pants. And it doesn't know or connect that this person loved the sweater. So this review, what is it? Is it negative? Is it positive? In this case, it would be classified as negative, which is not the use case or the end result we want. So let's have a quick look. You've been listening all day already to talks about AI. So let me quickly go to this. So I'm a programmer, and I moved into the space of AI, creating my own models like 5 or 6 years ago. So when I was programming in those days, I created a function, give the function some input, and then my function did my magic, probably a lot of if then else statements, and then it came up with an answer. But with machine learning, the answers and the function is a bit changed. So instead of creating the function, I let the computer create this function for me by providing it a bunch of answers. Run data through it, train it, and I get a model. And what is in that box? It is a function. Still, it is a function, but it is a function the computer made for me. So this is how I look at machine learning problems. The machine learning algorithms will create this function for me, which I can use in my broader programs, in my broader solution. So what is Azure Machine Learning Service and how can it help me create this function for me? So Azure Machine Learning is a set of Azure Cloud services. So that is very important already. It is not one. It is a group of services together, which you can control using the Azure CLI extension, the Python SDK, or through the web interface. And it enables us to prepare data, build models, train models, manage our models, track, experiment, and deploy models. So basically it covers the whole space from preparing data up to deploying the models. So let's first dive into something creating. Before we get started with our custom machine learning project, it is good to have a baseline. I think as a baseline is very important, especially for companies like Tailwind Traders, because a baseline enables them to estimate the results before they just go and grab the state-of-the-art buzzword model and put it in production. So Azure Auto Machine Learning enables you to very quickly get started with building baseline models without even having to write a single line of AI code. And it works kind of as it is. It works as follows. You provide your data, the task that you want to accomplish, and the constraints for the task. And what it will do is it will identify patterns from your data. It will try to apply them to many different models, train these models in parallel, and then it will return the best baseline model for your task given the constraints. Then you can get started with the model in production and improve it later on. Probably there's some cool animations in this slide. So we have input data. Azure Machine Learning will try out all these different models for us. It will run over. I think there was also a presentation like earlier in the day about automated machine learning. So it tested out a lot of models. And then we get our optimized models. So let's take a look at Azure Machine Learning Service. And especially we're going to zoom into the part automated machine learning now. So this is Azure Machine Learning. It is accessible by ml.azure.com. You first have to create the resources in the Azure portal. And what you will get is you will get a container registry, you will get a key vault, you will of course get the Azure Machine Learning Service for you, and you will get a blob storage. And all those things combined is called Azure Machine Learning Workspace. You need them all. So if we can look here at my machine learning workspace, here we see we have home. Here we have the ways how we can create our model. We can use notebooks, type it from scratch, which we're going to do later. We have automated machine learning. We're going to dive in that in a few seconds. And we have the designer, and the designer is a drag and drop interface. Then we have our assets. We have data sets, experiments, pipelines, models, and endpoints. Also going to dive into a little bit of that later. And then we have our store, our things, how we can manage this thing, like the compute and our data store, and we have some data labeling tool. So data stores hold the connections to all our data. It can be SQL servers, data warehouses, blob storages, it doesn't matter. So let's go to automated machine learning. I've already run it because you see it takes 28 minutes and we all don't want to wait 28 minutes to see if something is going to happen. So, but we can start and create a new experiment. So the first thing you need is data. So you have to create first a data set. And data sets are easily created by saying create data sets, select your local file, or your data store. You can even point to web files, or you can use your open data sets. So here I have my clothing automated machine learning data set, and I can explore that. And then hopefully it will show me what is in here. But basically what is in here are a bunch of reviews with a score if they're positive or negative. And we cannot peek in the data here. Okay, we can absolutely peek in the data here. So we will select our data set here, and then we have first our data preview. And now it should load like the top 20 or 30 or 50 from this data set. This data set is available on the GitHub if you want to try and do this at home. You can do it. It's a big data set, but still. Yeah. So here we see our reviews. Loved this. It's so pretty. Rating is a 5. I love this. Love this jumpsuit. This is perfect. So here there are thousands of reviews. I was really hoping to like this, but it does not look the way. It's a 1. So this is our data set. So we select our data set, click next. And then we have to configure our run.
Hank, is it like possible to use a data set that comes from a SQL database, for example?
Absolutely. You can just select another data source under data sets. Maybe we can do that. So here we can create a new data set, and from a data store, and the data store can be so this is how it works. It has been a while I've been doing this. So you go to data stores and create a connection to any of these data stores. And from these data stores, you can make a data set, and those data sets you can use in your automated machine learning. So we see Azure SQL, MySQL, data lake storage, file share, blob storage. So I mostly use blob storage because I mostly do images. So here we have our data set. I will not click view again. And here we can create a new experiment. This zooming does not really work. I zoom out a little bit. So we can say, we can just create a new one. We say Dataminds. Then we have to select the target column, which column we want to predict. This is actually, we want to predict the rating. And then you select a compute cluster. So I have 3 compute clusters. I have Bumblebee. This is a CPU-enabled cluster, and Optimus Prime. This is a GPU-enabled cluster. So I'm going to select this compute cluster. I will click next. And here I can configure what my type is. So I want to choose for classification, and you can enable a deep learning if you want. Click finish, and it will now actually create automated machine learning tasks. It will start spinning up my cluster, picks out all the different algorithms, runs it, and will compare the result. So this will run and will eventually be done. But let's go back to another run I did this morning and see what it has delivered us. So I said it is doing a lot of runs against different algorithms. So here we see what it has all done. These are all the other runs. And it delivered us a bunch of models, which it tested for the most for accuracy, for the prediction. And here it see that run 28 out of a lot has given us the best model with an accuracy of 98% with the algorithms. I'm not a machine learning expert in that extent, but these algorithms were exactly the best. We can click view explanation, and here you get a lot of more insights in the model. Pretty cool. So this is how you can come to your first model. And of course, we have a lot of docs about it available. So you can go to this short link and read more about it. There are also a lot of good tutorials there on that website under how-to guides and references on how you can do this yourself. But now let's move on to a little bit more advanced machine learning models where you actually have a little bit of more influence on the algorithm you're going to use to train your model. We are going to use in this example the NLP Architect Aspect-Based Sentiment Analysis framework by Intel AI. And we're going to use Azure Machine Learning to manage Tailwind Traders machine learning challenges. And here I say Tailwind Traders, but probably it is for every country, every company that wants to do it at scale. Because there is something that they need. There are always lots of things you need to manage as a team. So first of all, there are environmental dependencies. You know, if you have Python on your laptop and one does a pip install and the other one, you all get different versions of everything. So you need something to manage that environment. You also want to enable cross-team collaboration and set the appropriate access levels for people who can actually access the training data. And how do you share a workspace? How do you update it? Then there is for machine learning, of course, you have mostly a lot of data that needs to be in a central place. We don't all want that spread over everyone's laptop. And we all don't want to give everyone a bunch of CPUs in the local machine. So there has to be a centralized for that. Then there, of course, there is compliance and interoperability. We have seen probably, I think, 2 talks before. There was a big talk about how to do interoperability from the models. And we want to have something like distributed training so we can just walk away, close our laptop, go home, and come back and have our model done overnight. So the challenges of distributed training. We have something to manage our dependencies and containers. We want to enable scheduled jobs, distributed data, scale our resource, provisioning our clusters, gather more results, secure access, and handle failures. And of course, Azure Machine Learning Service can help you with that. So if we look at a typical end-to-end machine learning process, it all starts with preparing our data and having it at a centralized place so everyone is training the models against the same data set. Then we want to experiment, and not everyone wants to use the same tools. Some people want to use Jupyter Notebooks, the other people want to use Visual Studio Code. Everyone has their favorite when that is about IDAs. Then we need a centralized place for training and testing our model so that every time the same things are being used, so we create a repeatable process. Then we want to register and manage our models in a centralized place. And we want to enable that people can trace back where that model came from, which data was used. So there needs to be this central place where all the models are there. And then we want to pick up that model, that function we have created, wrap that in a piece of software, and monitor and deploy it somewhere where people can actually use that. So Azure Machine Learning can help us orchestrate and facilitate that whole process. And to get started, we need to actually do three things. First, we have to prepare that Azure Machine Learning Service environment. Then we need to start experimenting with our model and our data. And then we need to pick up that model and deploy it somewhere. So let's start with how to get started, preparing our environment. So all the code in the slides, and I'm going to show you now, is going to be in Python. So what we need to do is actually to create this workspace. So we boot up a new Jupyter notebook and we say workspace create. We give it a name, subscription ID, resource, and a location. Here I'm specifying a location. So before you create this workspace, you want to look into something before picking the location. So we in Western Europe, we have access to most of the virtual machines. But not all regions have access to GPU-enabled machines. So you want to spin up one of these workspaces in a region where they have GPU-enabled machines, if you want to use GPU, of course. So we create our workspace and we write out a config file. That config file we can check into our Git repository, and everyone else can connect to that config file and say workspace from config. So it'll pop up with Azure AD login, you log in, and if you have access to that resource specified in the config file, you will get access. And this is what you get. We have already seen it. So but let's dive in a little bit deeper in detail. So what are we going to use? We're going to use datasets. Under datasets, you register your known datasets. So we have already seen it with automated machine learning. The dataset is there. We can update and manage the dataset. So the cool thing is now that everyone can connect to actually the same dataset in code and doesn't have to spy. Doesn't have to point to a file on their hard drive. And then there are experiments. We already saw it a little bit. I clicked very fast in automated machine learning. But under experiments, you keep track of your training runs. And with automated machine learning, a training run can have a lot of child runs. So, but here, everything is gathered. The training scripts, to the output, to the log file, all the links to the models and where the data came from. So this is the glue that is holding everything together. Pipelines, we're not going to dive into that in this presentation, but you can create Azure Machine Learning Service pipelines, training workflows that you can kick off, like let's say every night, retrain on the new data, and then evaluate the model in the morning. Then there's models. This is the model registry, the place where you can register a model and other people can connect to that model registry and pick a model out. Because I think myself still as a developer, I always compare it to like the NuGet kind of repository. You connect, you pick out a package, specify your version number, and you will get that package and embed that function in your software. And this is how you can see model management also. You say, I want to have this automated machine learning model with name Hank, version 3, I'll pick it out, and I can use it and update it later on if there is a new version available. But if you work like this, that you check out models in like a build process, then it is clear that you've updated your model by, for instance, a Git commit. Everyone can see, hey, this function is updated to version 5. Exactly the same as I would do with a NuGet package. I would never update a NuGet package without probably testing it.
Henk, another question.
Oh, perfect.
You're talking now about models trained in the cloud. Would you be able to use these services when you do your when you do training on premise?
Yeah, absolutely.
Okay.
You can actually, the experiments will not really work for, I think, but you can use the data sets and absolutely use the model management. So you can check in all your models anyway.
Okay, cool.
Yeah, and then we have endpoints. There are two types of endpoints. The real-time endpoints, that is where our deployed models wrapped in software live. And then there are pipeline endpoints. And these, if you publish a pipeline, you can later on kick them off with a call. There's compute. Here you manage your different clusters. And there are data stores. And these manage the connections to your data. So we already touched a little bit about it. But if you connect to an SQL server there, you provide your credentials there, they're nicely stored in an Azure Key Vault. In your Python code, you can just say data store connect to data store Hank, for instance. So the first thing after that we have a workspace, what we need is compute. And you can create compute with 2 lines of code. So Azure Machine Learning Compute, provision this cluster for me. Use virtual machine size standard NC6 or NV6, and C6 the C is for compute, and the N series have GPUs in it, and this is the cheapest available GPU machine there is. They're around $600 if you can have access to the promo ones. You specify how many nodes you want to have running. So minimum nodes is 0, maximum nodes is 6. And this means if there is nothing to do, these virtual machines will shut down. And for instance, if we do automated machine learning or hyperparameter tuning, it will spin up maximum of 6 nodes. Then when we have this configuration, we say compute target create, wait 15 minutes, grab a cup of coffee, and then our compute cluster is there. Third thing we need is to have access to our data. And our data in this case is on a data store. And you get by default, you get one data store, default data store. It's also a blob storage. It is a blob storage that is created when you are creating your workspace, or you can connect to any data store in the cloud. In any data store, any blob container in Azure, that is the correct phrasing. So you give the name, container name, account key, and account name. This is all stored, and later on you can just connect by saying data store get, data store Hank. So let's have a look at a notebook where we're going to create our own model. So for this, I'm going to use a Jupyter notebook in the cloud. Actually, part of Azure Machine Learning. So I'll go to notebooks, and here I have my user files. I can create a new file, and I can create a new notebook here, which everyone can access. So I've already created these notebooks. Go to these notebooks. Here I have my notebook. And here we see that there is also an inbuilt notebook experience. But you can also say, open it in Jupyter. So one thing you need to know is that you need compute to run these notebooks, and that compute has to be running. Otherwise, it doesn't work. So you go to compute, and you have to create a compute instance. So I say create new, we say test. We can choose which type of virtual machine we want. For the Jupyter notebook, if you're going to do the training in the cloud, you can just use a cheap CPU-enabled machine, because Jupyter notebooks don't take that much compute power. So you can just select, give me a D1. You can specify if it has to run in your own virtual networks, if you want to have SSH access enabled. So you can really customize this compute to your needs and actually have it secure in your own virtual network. So I already have this one created. So one thing you want to remember is that you stop it when you're done with your Jupyter notebooks. Otherwise, it will not automatically shut down. And there is no way of actually saying, please shut down at this point in time or every evening. So don't forget it. So when you go to this notebook, you can select on which compute instance you want to run this notebook, and then you can select, hey, edit in Jupyter. So here I have a Jupyter notebook that is running on my Cliff Jumper West Europe Azure ML instance. Here we go. So if you all navigate now to this thing, that will prompt you to log in with your Azure AD account. So the first thing we do here is actually start with importing a lot of dependencies. And that is my personal taste, that I put all the dependencies I need in the Jupyter notebook in the top thing, so we later on don't see them here. Then I specify which cluster I want to use. My cluster is called Bumblebee because this is a CPU optimized framework that we're going to use. Give my experiment name, give the name of the model we want to produce, and here this is the Azure Container Instance name where I eventually want to have it deployed. So setting up the environment, creating a workspace, creating compute, and setting up the storage. So already, obviously, this workspace is already created because I'm in a notebook, in a compute instance running in it, but I will still need to connect to this workspace. So I don't have to make any configuration files. I can just say workspace from config, it will load in the config and it will work. Connect to my compute target, we can actually run this cell. We connect to the workspace, Cybertron in region West Europe, connect to my compute cluster Bumblebee, connect to my workspace here and my, sorry, we need to come to this Jupyter notebook. Still the same, but here we'll do it a little bit in phases. We first go to our workspace, using workspace and region name. And then we're going to see if there is already a compute cluster available. So we're trying to connect to our compute cluster. If it gives an exception, we will just provision a new Azure Machine Learning compute. We can choose for low priority virtual machines. We can choose this virtual machine size here. Then we say create, and we will wait for completion. I already have my compute cluster, which we can find back here under compute clusters. Click on it. We have one node up and running. I have to shut it down. I should not forget it. I'm using standard D3 V2 machines, 4 cores, 14 gigabytes of RAM. It's a CPU enabled. It's low priority. It can spin up maximum of 8 nodes, and it will wait 120 seconds before it will shut down. You can edit this later by code, but you can also do that in the interface here. Okay, so here we are. We connect to our Bumblebee and we connect to our default data store. So now it is time to continue and actually start working. So now we can all work together in this workspace. So we have done a workspace, compute, and storage. And now it is time for me, I find this the most fun, is to actually experiment with our model and with our data. So the first thing we need to do is to create an experiment. And this experiment is the glue that holds everything together. We need to create a training file. That is actually the file that will deliver us the model, and that is being run in a Docker container on our compute cluster. We need to create an estimator. And the estimator is the configuration for the Docker container where your training script is going to run in. So you can give this estimator parameters. You can tell it on which compute cluster to run and which packages need to be installed in this container. Then we need to submit that estimator, that configuration, to our cluster. We'll start building the Docker container according to our configuration. So pull in our scripts, to start training, and it will start sending output back to our experiment. And there are some Azure ML widgets which we can connect to that experiment so that we can actually see what is going on in our Jupyter notebook. So let's create our model and run an experiment. So first, we're going to create an experiment or connect to one that already exists. So let's do that. Done. Just running this cell. Under experiments here we can find Epson. And here we see that I have 2 successful runs. And here's a filter. You can also see that I have a lot of failed runs, but I always hide them like a little bit. So let's connect to a run that actually succeeded. That is run number 4. So here we can see a lot of things about our training data. So we have details, we have metrics that were being logged, we have if it had child runs, if it was automated machine learning or hyperparameter tuning, here we would find back all the child runs. We have outputs and logs, so here we can see what happened underwater, which outputs are generated. We have the snapshots. The snapshot is the training scripts you actually submitted. We have explanations and fairness. This notebook. So now we have our experiment and our experiment name. So now we're going to specify this, this estimator. So we tell it where it can find the data, and we tell it which type it has to use. There are 2 types in this example. From NLP Architect, we can use either a large dataset or a small dataset. The small dataset will just show that it works. The large dataset will actually train a good model. Then we tell it where it can find the scripts. So if we go here, open, we can go back to the directory scripts and here see our training script. Didn't expect it to happen like this, but here we see that it's importing things, parsing arguments, so on. And in the end, it is just delivering us a model that will be saved in an outputs directory and will be copied back to our experiment, but later more about that. So here we have our script parameters that we parse into. We tell it to run on our Bumblebee compute cluster. You can set environment variables, which is really helpful. So here we tell it that it has to use a CPU configuration and tell it to execute train.py. And these are the pip packages that need to be installed. And I've learned that it is very handy to actually specify version numbers here. We will submit this estimator to our experiment, and then we can ask, hey, give us the details from this experiment. And it will look like this. This experiment takes around 30 minutes to train. So I've already loaded a previous experiment here so we can see the outputs. So what you would normally see is it would just show real time this. Which one? It would show real time what is going on in the estimator. So if you say print in your script, you will actually see it there. And here you can use some things to log. So one thing I wanted to show you about this training script is that you basically can use every training script. That is, if it is a Python script that runs on your local machine, you can just pick up that Python script. But there are 2 things you need to remember. Everything the mod you want to save from that script has to be saved in an outputs folder. So where do we do that? Here we, at the end of our training run, we create an outputs folder and then save these 2 files that this model has created in outputs. If you save something in outputs, it will automatically be copied back to your experiment and be accessed by outputs here. And there you have these files. Probably shouldn't have clicked on it, but here are the aspects and the outputs of the model. So don't forget that, because otherwise the Docker container shuts down and all your output is gone. Your model is, and you did it for nothing. Another thing you can do is you can connect to the run context, because automatically the Azure ML package is installed and it knows in which context it is running. And then you can start logging variables to, and you can start logging variables to that actual run. And these variables are being saved under their names. And you can see them real-time changing. So these are one-time variables. But for instance, if you use, if you go to another experiment I normally do with some PyTorch, under no, absolutely not. This is this one. Then on the metrics, if you log floats under the same name every time, so every iteration you log the accuracy of your model, you actually get cool graphs which are saved within your run and which you can actually compare here over time. So you will see which runs are performed the best. But that is another type of model. So let's go back to our Epson model run 4. Okay. Our notebook. So here we see, and it will automatically switch for you. So the first time you run this experiment, it will take a little bit longer. It will take 5 to 10 minutes longer, because that first time it's actually building this Docker container where this estimator is going to run in. And it is basically according here. So if you don't change anything to like this line, these lines here, it will start reusing the Docker container. But if you change here a version number, it will automatically create a new Docker container for you and add those 10 minutes extra training time to the training for you. And then when we're done, we can register our model. We just say run, register our model. Where can you find this model? What is the framework being used? It's TensorFlow. Which version of framework is being used? Yes, this is a very old version, but it worked. You can add a description, you can add some text to it, and you can specify the preferred resource configuration. So this basically says, if you want to run this model, then at least use 1 CPU and 2 GB of memory. It's helpful. It's not a must, but it is helpful. So here we can actually run it. We can register it. Actually, that will work because I'm connected to this previous run here. And we have now registered our model as version 11. So we can now go to our model management. See here, model 11 is registered. Like now. We can click on it. And we can see some details. We see here our tags, we see our description, our framework, and very important, we see which run has generated this model. So we can click on that, go to this run, it's actually a run 3. And here we can see on which compute target it has run, which training script, see which models, we can here see some properties, we can here see the metrics back. Images we don't have, we can read all the model. Here we can see actually the output. And on the snapshot, we can see which training script was used to actually deliver us this model. So everything is retraceable. Or not retraceable, everything is traceable. And if you use a data set, I now directly grabbed it from a data store. You can actually see which data set has input data set it has created, and can go back to the data set and see which version was used and which exact files. So I would recommend, if you do this, you use always a data set instead of looking directly at the data store. This notebook, here we have version 11. So I've done a lot of things. We had our source data file, we run our estimator. Let's actually download this model to the temp directory and see what is going to happen. These are the two artifacts that our training script delivered to us. We load it in and we're going to give it 3 sentences. Love the sweater, but hated the pants. Really great outfit. I really like the shirt. The shoes are bad, but a perfect blouse. Run it, and then we will visualize it. So here we see it went very fast, but it really ran. Sweater, loved, positive. Pants, hated, negative. It's positive about the outfit, positive about the shirt, negative about the shoes, and positive about the blouse. Really cool, I personally think. So let's move back to our presentation. So to illustrate a little bit better what actually happened, because there are a lot of things behind each other, and for me personally, visualizing it really works. So we were in this notebook running on a virtual machine or compute instance in our Azure Machine Learning workspace, and we say submit. At that moment, it copied everything in our data pad. So it copied our training scripts and copied them over to the experiment and also our configuration. It started creating these Docker images, or reusing a Docker image, deployed those Docker images to our compute target with our configuration and our data in it. It mounts our data stores. So if we point to a blob storage, in those Docker containers, there are available as file shares. So we can just go to /mount/datastore_x. And when the Docker container is running, it executes our training script, and that training script will just does what is in there. And in the meantime, it streams out all the logging to our experiment. And if we run our widget that is connected to our experiment, we can real-time see what is going on. And when it is done, just before it shuts down, it copies over everything that is in the outputs folder and saves it under the experiment. The last thing, registering the model, I've already showed you in the notebook. We say run register model and say give the model a name and tell it where it can actually find those models files. We've already done it and tested our model. It was a little bit ahead. So we registered and tested our model. So now it is time to actually pick up this model and deploy this model in production. And for that, we need to have our model scoring file and our environment file. Push these two together and we get a Docker image. The scoring file looks like this. So what we do is we need to load our model. And you probably all worked with models, but loading in models takes a lot of time. At least if you do a computer vision model of like 100 to 200 megabytes, you don't want to do that on every request. So this scoring pie should have an init function that when it starts up, it loads in the model. And then it has a run method that is called every time the endpoint is called. And then uses the already loaded model and only does the inference of the model and returns the prediction. So your requests are really fast. An environment file is basically a file where you specify your conda dependencies. So install TensorFlow, install OpenCV, and write this file under my environment.yaml. You create an inference config. So you have your scoring file and your environment file. You say inference config, runtime is Python, this is my scoring file, my environment file. So now we have the inference config. And with that inference config, we can deploy we can deploy it to either an Azure Container Instance or an Azure Kubernetes service. Or it basically is a Docker container. You can just connect to that Azure Container Instance and pull that model out and deploy it wherever you want. But to deploy it to Azure Container Instance, you just specify how your ACI web service has to look. 1 core, 2 gigabytes of memory. You can either specify there or pick it from the model you're going to use. And then you say model deploy. This is the name of the service. This is the model. This is the inference config. And this is your Azure Container Instance deployment config. And it will create this Azure Container Instance by default in the same resource group as your Azure Machine Learning Service workspace is created. So let's deploy something and run something for real without an Azure notebook. Deploying. We can load in the model. You can just say model, give it a name, and then it will load the latest model. You can also specify here version, and then it will load in, let's say, version 10. So this is how you get to your latest model. And then you can multi-model download. So we create our environment. Needs to have these pip packages. And here we say conda environment create. Use this pip package configuration. We create a temp directory, put this configuration file in it. We say that the environment create this, create an APSA environment from our environment file, and set this environment variables, which is very important. Create an inference config, point to this environment we have created here, and this is our entry script. Maybe a little bit double to do this, but create this inference config, and then we say ACI deploy, and here you see that I don't say 1 or 2, I say model, resource configuration, CPU, and the G memory in GBs, and I give it a nice description. So this is my deployment config, and then I deploy it to an Azure Container Instance. This takes about 10 minutes, so we're not going to do that. But you say model deploy, give the name, which you specified all at the top. This is the model, inference config, deploy config, and you can overwrite this Azure Container Instance. If you set overwrite to false, it will automatically throw an exception because this ACI is already created. And if you set this to 2, it will just deploy this new Docker container to it. So the downside of doing overwrite is that you will have some downtime during your model, during your deployment. You can do the same with the AKS. So what you can do is you can actually create a attached compute here. Inference cluster here. You can create this new AKS service here, AKS Dataminds. And say create new. Do that. We can select a region, West Europe. We can say production test, how many nodes, network configuration, basic SQL. Let's say create, and it will create this whole Azure Kubernetes service for you. And you can deploy your containers into there, and it will automatically handle load balancing and all those things for you. It is really cool, but it takes some time to set it up. But deploying from a Jupyter notebook is not that difficult, because the only thing you need to do more is connect to your AKS compute. That is already there. Also create this deployment configuration, and then just also say model deploy, but the deployment target is now an AKS target. And these deployments go really, really fast if your Docker container is already created, of course. And then it is running. And now you need to get your scoring details so you can actually start using your created API. So here say deploy is connect to our latest ACI web service. And then it can just ask from that service. Yes. Oh, Sorry, I thought you were saying
Yeah, I'm
something.
saying you just still have 5 more minutes.
Yes, 6 actually. So we should be fine. We should be fine. So here is my scoring endpoint. Scoring endpoint. I will run this cell again. So here we say, give us the scoring URI. And here I have a small test website that will actually use my scoring URI to call the API to show it is actually working. So here's the scoring endpoint. So you can click on that. Just says text, meaning that it needs text as import hello. And then, of course, it is not a JSON thing because we need to format it nice. So we will go here, and this web service will actually do that for me. Here we see it is the same web service. And we will send this text to this scoring URI. And here we see a little bit more details even. We see here that loft is an opinion and sweater is the thing, the aspect. Height is an opinion and pants is an aspect. So this is the model we have created, and we have now created our own kind of aspect-based sentiment analysis model service in the cloud. Pretty cool. So I only have 6, 5, or 4 minutes left. So I really quickly want to go over hyperparameter tuning with you. So you saw me already having a few parameters with my model. And normally you would change those parameters, see how your model behaves, and then do that again over and over and over and over again. So there is this service, automated hyperparameter tuning in Azure Machine Learning Service that will help you for this, to help you do this. So we have the data set, we have our training algorithm, and then we have our parameters. And all those parameters will deliver different models, and our service can do that automatically for you. So let's go quickly to the demo because that always shows more than some slides. So here first we have to connect to our environment. And here we see instead of the normal script parameters, we give a few other parameters. The threshold, the maximum thing. And we say here, pick a random number between 2 and 5 and parse that in. We still have our estimator, but here the only thing we add is a hyperparameter drive config pointing to our estimator, giving our sampling data, and specify which metric we want to monitor. To do that, we submit, instead of the estimator, we submit the hyperdrive config, and then we can show it. So the thing we see different here is that we see a lot of runs of that same training script we saw in the previous one. So we can click on one of those, and then we get exactly the same information. And it is now listed as a child run there. Comes with the school graph. We just go up like stairs, and we see that model run number 9 has the best primary metric. And this is the best model that we want, that we should be using. Some other cool graphs. And we can ask it, hey, give us the best model. It's 9, and we download, and we register only that model. So, a lot of doc slides. So if you get your hands on the presentation, you can just follow this, learn more than my 2-minute hyperparameters. What have we learned? We have seen text analytics with cognitive services, how to build a model with automated machine learning, how to build an advanced model with Azure Machine Learning, and we quickly tipped how to optimize our model with hyperparameter tuning. We have, of course, more docs from where you get started, good links. We will all share them later on, and also learn things, certificates. And these are the best resources. I saved them for last. So if you want to go to this Medium article and learn more about Azure Machine Learning. That was it. So I hope you enjoyed it and enjoy the rest of the day. And if you have any questions, like 30 seconds to answer them.
Exactly. So if anyone still has a question or wants to ask, well, just want to use his voice to ask something to Henk, please don't hesitate to use the chat functionality or the raise your hand, so we can get you into the call. Thank you, Henk, already for your time. We know you're a busy person also, so we're glad to have you also on Dataminds Connect.